So in this section, we're going to be discussing momentum and something called impulse. And momentum is defined with the letter P. P stands for momentum. It's equal to the mass of an object times its velocity. So momentum is immediately, you can see if we're talking about velocity, that's a vector quantity. And so momentum is also going to be a vector quantity. And incidentally, I think at this point I would like to just do a little sidebar on vectors, which we didn't mention last time. But if we have a vector in two dimensions where this is our x-axis and let's say that's our y-axis, and we have a vector shown like this, vector v at an angle of theta, then we talked about the components of this vector, and we did that by drawing the box, if you remember. And we said that vector v with the magnitude of v at an angle of theta to the x-axis, in other words, if the vector makes an angle with the x-axis and that angle is theta, then the component of the vector in the x direction, which is this component right here, is going to be the magnitude of the vector times the cosine of the angle. And the component of this vector v in the y direction is going to be the magnitude of the vector v times the sine of that angle theta. So given any vector in a coordinate system such as this vector, let's call it, well, maybe we'll just call it d1, and here's our angle theta. This d1 is going to have some horizontal component here and some vertical component there. If I show you a vector in yellow, and this is our vector d2, remember this vector here only has a vertical component. It has no horizontal component. So this vector, no horizontal component. This vector here has a horizontal component and a vertical component. So this is the vertical component, this is the horizontal component of d1. So that's just a little sidebar. Now back to momentum. We said momentum is mass times velocity, and you must know this formula. This is the formula for momentum. So if something has a mass and it's moving, it's said to have momentum. Now the momentum can change, and the only way that a momentum can change is if a force acts on the object. And you might want to go back to the section or the chapter that we posted videos on when we talked about momentum and impulse. And I had drew the baseball getting hit or the golf ball, and we said that if you have some object of mass m that's moving with a velocity v, it's got a momentum of p. That momentum will be the mass times the velocity. If now some force F comes and pushes this object and acts, some net force comes and acts on this object for a time duration delta t, then the momentum P will change. So the change in the momentum is going to be equal to the force that's applied times the time interval that the force is applied. And that will produce a change in momentum, and this change in momentum is what we referred to as impulse. So it's this delta P, or change in momentum, that we called impulse. The impulse results from some force acting for a given or particular time interval. So a baseball is coming at a bat. It's got a certain momentum, and now the baseball bat hits the baseball. It makes contact. There's a force that's experienced or exerted on the ball for some time, delta t, and that changes the momentum of the ball. And in fact, you see that's true, because at first the ball is moving in this direction with a momentum mass times velocity in this direction. After the force is applied for a certain time period, the ball is now on its way this way. Assuming that the bat is swinging this way, it's going to hit the ball. Force is going to be applied to the ball, and now it's moving with a new velocity in this direction. So here the momentum is going to the left. Here the momentum is going to the right. You clearly see that there was a change in the ball's momentum. That change resulted from a force acting over a time interval. We also talked about an example for impulse, the egg. If you have an egg and it's dropped onto the ground, it's got a momentum. So here it is, it's falling because it's under the influence of gravity. And right at that point, it's got some velocity and it's got some mass, and so it's got some momentum. So its momentum here is its mass times its velocity, v, right at that point. And a force acts on the egg upward. So there's a force, and a very brief time interval is used to stop the egg. So if time interval is small, the force acting up on the egg is very large, and that changed the momentum from some initial value of mass times velocity, whatever this velocity was here, to 0. So we went from a momentum initial of mass times v to a momentum final of 0 because it wasn't moving. So this change in momentum was the 0 minus mv. This change in momentum was the force times the time. So now, what happens if you, to use the same example, have a pillow and you drop the egg, and now when the egg hits the pillow and lands here, it's got a momentum, mass times velocity, whatever the velocity is at this point. It's going from mv to, so its initial momentum is mv, its final momentum when it stops is 0, so its change in momentum is still 0 minus mv. That momentum is the force times the change in time, but we notice that this change in momentum is going to be negative mv here, same as up here. So they're both constant, or rather the change in momentum is constant, all right? That doesn't change from this situation to this situation. But what does change is the time interval. So if the time it takes to slow the egg down is increased, so this is a larger time,